So the Copernicus Climate Change Service is one of the 6 Copernicus services. And the purpose is to provide authoritative information on the past, present, and future climate to support mitigation and adaptation by policymakers, also private businesses, and anyone, basically. So the data is completely free, the products and the tools all completely free. And what you see in this slide is a kind of timeline of the products that we have available. So we provide observational data going back quite far back in time. Then we've got reanalysis products. So basically reanalysis is like observations, but it fills the gap in space and time of the observations with the latest state-of-the-art forecasting model. Okay, but it's the same forecasting model applied across the entire time series. So what you have is a very nice data set to enable you to analyze past trends in across different climate variables. So those are the data sets we have of the past climate. Then we also have products referring to the future, so seasonal forecasts and decadal predictions, and then so that's for seasonal forecast for the next season, and then climate projections going up to basically the end of the century, projecting how the climate may look across different variables according to different scenarios. So in the next slides, I'm going to talk about each of the types of products. So grouping them into the different climate data types, so starting with observations. So what you see in this figure is the essential climate variables. So these are variables as defined by the Global Climate Observing System that really characterize the climate. And you can see they're grouped into different, variables of the surface, of the atmosphere, hydrosphere, the cryosphere, and so on. So these are variables that can be measured and that accurately describe the state of the climate. And in this slide here, you see a set of climate data records of essential climate variables. So these climate data records are basically time series of essential climate variables going far enough back in time to be able to really characterize the variability and trends across different variables. So these are all available through C3S. And of course, WEkEO. And in terms of observational data, it's not just satellite data, also in situ observations we make available. So these are point observations over the surface, over the upper air, from ozone sondes, radio sondes, and so on, but also gridded observations from different in situ networks. And in addition to this data, we also have this data rescue service. So basically, the data rescue service facilitates and coordinates the rescue of weather and climate data from all over the world, from different sources. So from old ship logs, for example, that are not digitized. And through our online portal, we collect and share this information. And feed it into international repositories, that promote tools, best practice and standards for all aspects of this rescue process. In this figure here, this is actually quite a cool animation that shows the importance of in situ data. So if you look at the date that's iterating over the different years from 1940. Okay, so obviously from the 1940s, we didn't have any satellite data. So the in situ data was absolutely crucial to understanding the past climate. So this is an animation of the input used in the reanalysis data that starts long before the satellite era. So now leaving observations and going into reanalysis. So the Copernicus Climate Change Service provides different reanalysis products. So basically reanalysis is like the flagship product of C3S because we're using the observation data, but also the forecast model that ECMWF provides. And we're using that to really provide a very nice consistent data set of the past decades. So different reanalysis products include ERA5. So that's the main global reanalysis at 30-kilometer resolution hourly and at different levels of the atmosphere. We also have a slightly higher resolution, 9 kilometers over the land. And then we also have the regional reanalysis. So these are high resolution over certain regions. So these are kind of downscaled high resolution reanalysis. And we have that over Europe and over the Arctic. And this is just a figure showing some visualizations of this reanalysis data set. So you can see they're gridded, they don't have any gaps. And also, yeah, you can see the difference in resolution, for example, between the Arctic, the regional Arctic reanalysis, the CARA and ERA5. So the Arctic is the fastest warming region on the planet. And actually, this figure here shows how accurate this data is and what you can do with it. So the figure on the top is a time series going from 1950 to pretty much to the present. And it's at different layers of the atmosphere. So starting from 1,000 hectopascals from the surface to the upper atmosphere. But each point on this figure is just one global average temperature. Okay, so it's global average temperature. It's just one measurement for the whole world. And despite that, this is an aggregation for the whole world, you can still see blips corresponding to certain events. So, for example, these big volcanic eruptions, okay, you can actually see a blip in the global average temperature caused by these big events. So this just, this shows how accurate this data is. And of course, it's not just the single figure for the global average. We also, we have a gridded data set over the whole world. So in addition to these core reanalysis data sets, we also have some value-added data to support different sectors. So for example, for the agriculture sector, we have indicators useful for stakeholders in agriculture. Things like relative humidity at specific times of day relevant to the crop season. And we also have them for energy and other similar data sets. Now, I've also included a kind of grouping for climate intelligence. So before talking about climate predictions and projections, I just want to say a few words about climate intelligence. So what we do here is we collect all the data and we analyze it. We provide monthly bulletins, also the annual European State of the Climate, and we support media outlets. We provide nice visualizations, and you can really see the media impact across the years that's massively increasing. So there's a lot more visibility now, and the trend seems set to continue. This is an example of a nice animation just showing, well, actually a nice animation of a not so nice message, basically showing the time series of global surface air temperature anomalies. And you can really see that 2023 was way above average. Also 2024 was a new record, but the 2023, you can really see what a marked difference it was compared to the past. So these figures are available on the website, figures, animations, and bulletins. So the monthly bulletin, and this is a little video of the European State of the Climate. So this year it was done together with WMO, and it's characterized, it's providing a summary of the key events over the last year in Europe and the Arctic. And yeah, all of this is available as a bulletin, also in figures. So I'd suggest having a look at this in more detail. We also provide tools, so not just data, but also applications to facilitate exploration of this data. So those who do not want to download a lengthy time series, calculate the climatology, calculate the anomalies with respect to the climatology, you have a lot of data to collect. here you have an application where you can just see the climatology. You can zoom in, you can click on a point, see the time series. It's a much more user-friendly way to explore this data. So that's also part of our kind of climate intelligence activities. Now, going on to the data sets of the future, so predictions and projections. So C3S makes available seasonal forecasts, and this is from a multi-model system. So it's not just ECMWF providing these forecasts, but different data providers. And we also provide the ensemble of all these different providers. Or you make the data available graphically, well, as numerical data, of course, but also in graphical charts and time series, and also as verification data. So if you want to see the scores of the predictions. Then going further ahead in time, so climate projections. So these are projections of the future climate according to different scenarios. We make available, so basically we're brokering this data. We're not doing it ourselves, but we're making it available. So this data is also available on the Earth System Grid Federation, on ESGF, but through C3S, it's a little bit more user-friendly. It comes with quality control, with data tutorials, with a seamless kind of data access system, because there are many different models provided by different people. So it's useful to have a unified portal where you can access this data in a kind of user-friendly way. So through WEkEO, of course, you can get this data. You can get the data for the global climate projections, so CMIP 5, CMIP 6, and also for the regional climate projections. So these are kind of downscaled climate projections, high resolution over a particular region. And these are the Cordex regions, the Cordex regional climate projections. So similarly, we have an app to help you explore this data. So this is called the Climate Atlas. So the Climate Atlas is, well, you can do even more than the previous one I showed, Climate Pulse. So this one allows you to explore many different variables from reanalysis data, from climate projections. And yeah, again, you can zoom in, you can click on certain points, you can look at climatologies, anomalies, various different trends, and you can really play around and explore different scenarios. So yeah, so this is a very nice user-friendly tool. A few slides on user support, quality assurance, and training. So C3S is an operational service. It doesn't just provide data for researchers to do, without any kind of support. We do provide, a lot of operational support. And one of the things I'd like to mention is the evaluation and quality control. So the data sets have gone through a rigorous quality control process to ensure that they're fit for purpose, to identify what the purpose is and to communicate that to users. And also to make sure that there's uncertainty information, that the metadata is clearly there, that there's good documentation, and any issues are flagged and addressed. So, so this is one big component of C3S. So, of course, you have the WEkEO user support. We also have user support at the service level of C3S. So there you can find information on documentation and how to raise a ticket and so on. And of course, you provide a lot of learning resources integrated with WEkEO. So on the WEkEO Jupyter Hub, you will find Jupyter notebooks showing you how to explore this data. In addition to Jupyter notebooks, we also have e-learning modules and explainer videos that are available. So I'd recommend exploring these resources. And then I know that EarthKit is going to be presented also by Annalena, just mentioning it very briefly here, that this is an open source package to process climate data. It's basically a wrapper for Xarray and these other libraries like Matplotlib and Cartopy and so on. There are different packages, and it's really a convenient way to explore the climate data in Python. So we have some tutorials showing examples of how to apply EarthKit for different processing routines. So just to summarize, the Copernicus Climate Change Service is a recognized global voice on climate, informing EU institutions, but also the IPCC and UN institutions and public and private organizations throughout Europe and beyond. It's truly a European effort with offices in various different countries. So we have Bonn, we have also Reading in the UK, and we have Bologna, where the data center is in Italy. But we also have contracts and agreements with every EU member state and all Copernicus contributing countries. We're really informing the global discourse on climate through products that have become so well used and relied upon. It's really a common resource for many organizations, including media outlets, public and private organizations. So it's a trusted, authoritative, and operational source of information on climate for everyone, pretty much. And with that, I finish my presentation, and hopefully there are some time for questions. So let me just...
Thanks a lot for your presentation, Chris.
And I'll stop sharing.
And so we have a few questions. So we will start with the first one being about the Climate Atlas. So is the Climate Atlas like a viewer, or does it work differently?
Yeah, so the Climate Atlas, is like a viewer. And what it enables you to do is to view the data. So you can visualize it. You can visualize it in as a spinning globe. You can zoom in, you can click on a particular grid. And then for that grid, you can then expand another dimension. You can see the time series. So it's basically a graphical user interface for exploring the data to save you from having to download all the data and process it by hand.
Okay, thanks a lot. A question about the catalog. Have you already included data from the new EarthCare satellite level 1 products? Oh, okay.
No, okay. So I don't know to what extent these have been assimilated already into the products. I can try and find out and get back to you.
Okay.
But at some point they will be assimilated. Yeah.
Okay. Thanks a lot. This question, isn't ECMWF in charge of the Copernicus Atmosphere Service also? How do you handle both services?
Yeah, it is, exactly. So ECMWF is the entrusted entity for both C3S and CAMS, so the CAMS being the Copernicus Atmosphere Monitoring Service, relying on ECMWF's expertise in forecasting. So it's logical that we handle, that service as well. So CAMS provides more kind of forecast data, so over shorter timescales. So we provide forecasts over the next 4 or 5 days. So 4 days for the European air quality forecast, 5 days for the global atmospheric composition forecast. We also provide reanalysis data, but reanalysis data for atmospheric composition. So different chemical species and aerosols. So yes, similar products, but different timescales, not so much climate, it's more on the short-term forecasting, and it's more focused on atmospheric composition. Yeah.
Okay, thanks a lot. Next question. Can the data be cleaned, manipulated, or visualized using MATLAB with the tools you're using for local or regional climate projection analysis?
So you can use MATLAB, of course. The data come in GRIB or NetCDF formats. So, of course, you can use MATLAB for doing this kind of data analysis. We have tutorials in Python. We don't have so much support material for MATLAB. But of course, you can, if you're more familiar with MATLAB, then of course you can use that.
Okay, thanks. We also have a few questions on the model used. What kind of models do you use for projection and forecasting? And we have another one asking if the models are using a couple between ocean and atmosphere, for example.
Yeah, okay. So I'm not an expert on the models used for climate projections and or for the predictions. Just to say that we do, we have multiple models from different sources. You can find the full documentation of all those models on the data catalog. So if you click on more information, you find the full documentation. If you really want to know exactly what kind of models and the resolutions and the data providers, all that information is available.
Okay, thanks.
I hope that somewhat answers the question, or at least defers the question to where
Yeah.
it can be answered.
One question also, same type of question. What are the rules for using your data for commercial projects?
Yeah, so the data is completely free and available also for commercial projects. So you can use them, businesses can use the data as long as you cite the data properly, they can be used for commercial applications.
And yeah, I guess they also have to cite the data they used using the DY or something like that on the projects, no?
Yeah, so there are different there's a different licenses. I can't remember exactly which license, but if you look at for each product, you'll see the license, and it'll come with instructions on what the conditions are. But they can be used for free, so that's there's no doubt about that. Anyone can use them, and you can use them in for business purposes.
Thanks a lot. In the Climate Atlas, I can see that there is climatology available based on IPCC AR6 regions. On what basis are these regions, I think, maybe separated or decide is not country-wise?
Okay, so the climatology can be created on different regions, but also country scale, also different NUTS regions. So there are different ways to aggregate the data. The Climate Atlas provides different types of aggregations. So you can choose where you want to see the climatology, if you want to see it for a whole globe or for specific regions. It's not just the IPCC AR6. You can choose different aggregations. So yeah.
Okay, thanks. Okay, one more general question. From what I understand, for climate analysis and downloading datasets like ERA5, the CDS platform seems more suitable than WEkEO. Would you agree with that?
Okay, well, you can get the data from WEkEO. You can get the data also from the Climate Data Store. The advantage of WEkEO is that you have not just the C3S data, you also have data from other services, and you have the satellite data. So the advantage of WEkEO is that you can, for example, in the Jupyter Hub, you can get data from multiple sources and you can process all that together. Now, the actual data access mechanism, I think now it's becoming more and more similar to the CDS. There are probably still some differences. Obviously, if you go straight to the source, then maybe it's advantageous for certain applications, but the advantage of WEkEO is that you really have data from you can get multiple sources you can get data from multiple sources. So that's really the advantage of WEkEO. And of course, you've got the virtual machines if you want computing power. So yeah, I mean, you can get data from both the CDS or from WEkEO, and yeah, I mean, I think it depends on what kind of what your application is. If you're interested in using multiple data sets, then WEkEO is probably more advantageous.
Yeah, that's what I was going to say also. Thanks a lot. So a general question I think I can answer. Is there a WEkEO learning session that explains how to downscale climate data using machine learning? So at the moment, no, but it's in development. I think it will probably happen next year or something like that, using trying to using AI or machine learning in the tutorials we will present during the WEkEO session. So stay tuned, and it's a subject that comes back a lot, so we'll keep it in mind for the next session. Okay, I think we have time for 2 more questions. Is there a plan to I'm sorry, I can pronounce it, operationalize regional reanalysis SIRA as it is the case of ERA 5 land? SIRA is now available only until 2021.
Yeah, I have to get back to you on that. I'm not entirely sure what the plans are for Sarah, but I can speak to the regional reanalysis team and I can get back to you. So
Okay.
yeah.
Okay, I will put the question on the side then. And yeah, one last question before we have to move on. Does CMIP6 have any downscaled products for the whole world, like the Cordex dataset for CMIP5?
Yeah, exactly. I think the Cordex data sets are quite old now. The problem is that these climate predictions are still not considered kind of like operational products. So I don't know what the plan is, but I can try to find out and get back to you on what the plans are for CMIP6
thanks.
and yeah.
Okay, so yeah, I put both questions on the site for later answer. Thanks a lot, Chris. And yeah, so we have a few unanswered questions, but we will put them together in a post-event report with useful link and everything needed for you to have your answer. So don't worry if your question hasn't been answered yet. Thanks again, Chris, for your presentation and your participation.